Hello everyone and welcome. We are so pleased you could join us today. We've got some really exciting product announcements to share with you, focusing on three of them: a groundbreaking software development kit, a novel software service, and a unique application marketplace. We call them MAGES SDK, MAGES SIP, and MAGES App, all three key components of our ORamaVR mission, which is to accelerate the world's transition to medical virtual reality training. The main problem that ORamaVR is addressing is that medical training has not changed for the last 150 years and can't keep up. Because of this problem also, 4 billion people currently lack access to affordable surgical and anesthesia care. There is a projected growing lack of 18 million medical professionals by 2030 by the World Health Organization, and fatal medical errors keep rising. This is because the training is highly intensive. A master educator operates on a patient, and the trainee apprentice observes and then learns on the job, often practicing on real patients. Medical virtual reality training can change all that. It has been proven in clinical studies to improve patient outcomes. However, current VR content creation cannot keep up with the demand due to lengthy content creation time, high authoring costs, and a very large number of medical operations that they need to be simulated in VR. ORamaVR aims to accelerate the world's transition to medical VR training by offering an IT platform, MAGES SDK, that empowers institutions to massively create themselves high-fidelity medical VR simulations. These simulations are then being used by hospitals, medical device companies, medical schools, and medical training centers to train as well as assess their medical professionals. This award-winning platform, MAGES SDK, has been proven via 4 published clinical trials to provide skills transfer from the virtual to the real environment, 8 times improvement in the cost of production, and 8 times improvement in the time it takes to produce these medical VR training simulations versus current practices and standards. If you want to see the future of medical training, stay with us. We can't wait to show a glimpse of it to you today. I'm inviting now my colleagues Paul Zikas, Head of Product, and Nick Lidatakis, Head of Platform, to explain MAGES SDK in greater detail.
I am very excited to introduce our MAGES Software Development Kit, or SDK for short. MAGES SDK is the medical VR industry first software development kit that allows rapid prototyping of any shared, collaborative, networked medical operation in VR in a fraction of time and cost. By being layered on top of existing game engines, it allows harnessing all their benefits while providing a low-code, superior solution to developers. MAGES SDK draws its novelty from over 20 years of academic R&D and the following algorithms for state-of-the-art psychomotor and cognitive simulation for any medical training module and scenario. MAGES is an acronym. M is our custom multiplayer engine. A is for our analytics engine that works in tandem with our cloud services. G represents our geometric algebra interpolation engine. E is for our educational curriculum editor, and S for semantically annotated soft bodies. Let us take a closer look at all the pieces that our SDK consists of by starting with the multiplayer. Our mission with MAGES is to bring trainees together with the medical professionals, overcoming physical boundaries, to sustain an immersive training environment where you can join from everywhere, while all interacting with deformable soft and hard tissues. When you develop an application using the MAGES, you have an out-of-the-box networking support for complex, high-fidelity deformable surfaces and objects, meaning that you and your colleagues can immediately join into a virtual world together and experience the great capabilities of VR training. Developers no longer need to consider complex integrations with third-party frameworks, since we provide a complete networking integration within MAGES. Whatever asset you design to work on your VR headset locally is also automatically available on a collaborative experience as well. Our networking system proposes a low bandwidth, low CPU, and high visual fidelity collaborative way, featuring a great number of active users, with low latency, based on our proprietary geometric algebra interpolation engine. We are the first platform that overrides the standard Euclidean 3D matrix transformations by introducing geometric algebra capabilities in our pipeline. This framework allows 4 times improvement on reduced data network transfer and 4 times less computational resources for this task, which is very important for our physically based, deformable, soft and hard tissue simulations. This basically allows more people to join in the same virtual environment while reducing the latency to a minimum and keeping them all active participants, as opposed to the industry standard, where one is the active participant and the rest only spectators in the virtual world. The challenging part in VR is to synchronize all the interactive objects and avatars, which can be a huge task computationally. Imagine an immersive medical class with students and the instructor performing an operation with tools, medical instruments and implants while cutting, tearing and drilling in an unconstrained manner through physically based soft and hard tissues. Those objects and anatomical elements need to be in the same state for all the participants. We overcome this challenge by utilizing our advanced interpolation engine that transmits less data to the participants, while interpolating the needed values locally. Using this methodology, we managed to conduct the first ever collaborative VR orthopedic surgery, even since 2018, across 2 continents, 4 medical schools, and 5 cities flawlessly. Since then, many milestones were reached, with the last one being the increase of our maximum number of online participants to 300 per simulation room, with the capability of having 10 of these rooms at the same time. We believe the future of VR and the metaverse lies in the ability to connect people and ideas together, and we are more than excited to provide the best plug-and-play networking system so far. In medical VR training, it is extremely important to provide accurate user task performance assessment, capable of reflecting the educational impact in order to enable the trainees to identify their missing skills and weaknesses and improve them. MAGES SDK captures and presents the performance of trainees by analyzing hundreds of events per second. Those can vary from being incorrect hand-based interactions with specific medical tools to user-critical decisions over the patient's treatment. Our analytics engine is a core component of our SDK. Developers can use our analytics editor to assign a multitude of scoring factors like time, position, angle, and many more to each trainee action. Using skin incision as an example, we can precisely configure the correct approach with a few clicks. Then the system will automatically gather all the needed data to assign a final score to the trainee according to their performance. So, when a trainee makes a wrong move in VR, he is automatically prompted with a message to identify it on the spot. At the end of the simulation, the trainee will see a final report with the results, highlighting the warnings, errors, and critical errors, depending on the severity of their mistake. User reports are automatically uploaded to our cloud services to be accessible from everywhere. Our optimized event tracking system is also uniquely used to record complete scenarios with multiple participants. This is a new feature that we call VR Logger. It captures all the events in the virtual operating room, from avatar movements to wrong decision and actions, to reconstruct the simulation as it was performed. This is indeed a great tool for educational purposes, as students can retrieve the complete operation and relive the experience from a different perspective. Data optimization was a key challenge to achieve such a lightweight analytic capturing system that our SDK provides out of the box. The applications developed with our SDK supports the same capabilities with high precision and simple configuration. In our SDK, we introduce geometric algebra algorithms based on the algebra of William Clifford from the early 18th century. We are the first platform that offers real-time cutting, tearing and drilling of deformable and soft bodies based on the algebra of William Clifford. Mesh deformations are very complex to simulate, especially in VR, which requires a high frame rate. However, with this technique, we are able to deform, cut, tear and drill without compromising the quality of our physically based simulations. By using our SDK, you have full control over high-fidelity deformable surfaces in VR. You can modify the properties of a deformable model with a few clicks and then apply them in real time to your training simulations. MAGES SDK utilizes a gamified, rapid prototyping methodology to empower developers with the ability to create interactive behaviors in VR with the least possible effort. We introduce action prototypes, a new VR software design pattern which can be employed as a recurring solution to standard problems, as first introduced by Christopher Alexander in architecture. The implementation of such action prototypes was highly inspired by game programming patterns as an alternative paradigm for VR experiences. The action object reflects a structural module capable of generating complex behaviors from basic elements. In simple words, an action can be an insertion of a medical instrument, a skin incision, or an object removal. In this way, we classify the majority of tasks into clearly defined entities and reuse them to populate new VR simulations. Developers can utilize our action prototypes editor to generate actions without writing a single line of code. All action code is automatically generated for future customization, but the action score is already there.
Until now, we have explained what an action prototype is and how to create one. But what about the entire medical simulation? The main data structure that holds the actions together is our training scene graph, a modular, dynamic, and highly adaptive acyclic graph based on a structured educational curriculum. This is where the action prototypes are linked with the actions a trainee has to undertake in order to complete the steps of VR training scenario. Imagine a complex surgical, therapeutic, or diagnostic operation. Physicians, surgeons, and nurses need to perform a multitude of different tasks. We store all this information in the training scene graph in the form of actions as leaf nodes in a tree-like structure. Developers can create their own such training scene graphs using our visual scripting editor, an easy-to-use interface capable of managing the whole simulated training scenario. The simplicity of this tool transforms the VR content generation into a low-code process. However, the training scene graph is not linear nor static. Certain user behaviors can modify the scenario as the simulation goes on in real time and branch to different paths. Let's assume a trainee performs an error while operating on the virtual patient. The training scene graph will identify this and modify itself to make sure the trainee has the option to select the appropriate branching course of actions to correct or ignore the previous mistake. In certain scenarios, the operation can terminate if such error is critical and restart of the training is required. The training scene graph is more than just a data structure. On a different subject, we understand that virtual reality is not always accessible to people with disabilities. For this reason, our interaction system can automatically operate in a very similar visual manner without the need for a VR headset. In this way, users can interact only with traditional means like mouse and keyboard. We also found from our early adopters that this feature was quite useful during the development, as their teams could quickly test the application without the need for a VR headset. Cutting-edge computational science research in VR is one of the company's strongest beliefs. We are constantly trying to find new state-of-the-art algorithms that will have an impact on VR training for healthcare institutions and improve the fidelity and performance of our simulations. One very important aspect is to accurately depict deformable soft bodies and tissues like the human skin, both in terms of visual fidelity as well as physically principled, realistic behavior in networked virtual environment. To achieve this, we have created our proprietary solution for real-time interaction with deformable soft bodies based on our geometric algebra framework. We can very accurately represent this soft tissue behavior while keeping the computational cost low with our advanced geometric lightweight operations. The result is having these complex calculations being executed rapidly and effectively in any type of VR headset, desktop or standalone, in low latency networked environment. Interaction is an important component in VR since the users should feel immersed in the virtual world while keeping the overall simulation cost around 10 milliseconds per computed frame. Our SDK provides a built-in interaction layer for any type of virtual object. Our hand pose system imitates an intuitive way of holding or interacting with items without the need for extra work. These systems aim to enhance embodiment and minimize real-world distractions.
Hello everyone, I will now explain you about our cloud services. As the metaverse expands, there is an urgent need for a robust cloud system to collect and unify all of our data with ease. ORamaVR supplies a plethora of options for the user and product management, as well as data saving and tracking. MAGES apps are accompanied by the web portal, a single-page web application accessible via browser, responsible for displaying session analytics. After completing a simulation session, analytics are uploaded and tied specifically to a safe cloud environment. Individual users can access detailed version of their analytics, including score, time, warnings, error, and critical errors categorized by each product, session, and date. Organizations and universities utilizing a MAGES application might need a convenient way to view the progress and improvement of their members. Accordingly, users can also act as supervisors, allowing them to monitor the organization's analytics and progress. Users can also find useful information regarding MAGES through the web portal, as well as gain access to the ORamaVR forum to express any possible challenges they face and receive immediate support. On the other hand, through cloud services provided by MAGES SDK, developers can build, customize, and deploy their own cloud system to better suit their needs. Every custom cloud system is equipped with an administration panel that allows on-demand user registration and license management for each custom product.
I would like now to tell you more about our second MAGES product line, the MAGES Sim. The MAGES Sim are medical training simulations that ORamaVR custom develops together with you and following your very specific requirements. MAGES Sim are developed following success-proven methodology and using the powerful MAGES software development kit. MAGES SDK works on both leading 3D game engines, Unity 3D and Unreal. It also supports all commercially available headsets, as well as augmented reality HMDs like Microsoft HoloLens and Magic Leap. Using MAGES SDK ensures not only best results, but the fact that your simulations are future-proof as we keep enhancing MAGES SDK, with which you can continuously update and upgrade your MAGES Sim, or even create your own iterations of your MAGES Sim. Finally, once you have developed your MAGES Sim that you fully own and use to train and assess your teams and trainees, you can optionally decide to make it available as a MAGES app on the ORamaVR marketplace to allow the world to purchase a subscription to your simulation. We look forward to develop your MAGES Sim with you. Let's connect with some of the adapters of our technology, both in MAGES SDK and MAGES Sim, to explain how ORamaVR has contributed in reaching their goals.
Hi, my name is Stefan Tuchschmidt. I'm co-CEO and founder of the company Vertamade. We are one of the leading players within the surgical simulation, and what we usually do is we create very realistic hands-on simulation with lots of hardware and software pieces. Now, what happened with COVID is that all of a sudden our customers were asking for VR, goggle-based VR, and we wondered how can we do that in the best way. We already had all the assets, we had the game engine, we understood all that. But what MAGES did for us was really giving us an additional outlet, a VR outlet for our existing content, and to be able to create that content with really a minimal effort. And the team at Orama has been extremely helpful in supporting us and getting to results very, very quickly.
Hi, I'm Madeline Harlow and I'm the product manager for Simulation Online at Vertamade. Traditionally, we train fine motor skills using highly realistic simulation and hardware, and this modality is great for transferring those skills to the real world. But that doesn't mean that other modalities aren't also useful. And there's other skills that need to be trained that these modalities can do very well. And learning doesn't need to stop when the surgeon leaves our simulator. So now we're introducing new modalities to our portfolio to complete the learning pathway. And ORamaVR's MAGES SDK has made it very easy for us to add VR. Thanks to the SDK, we can create high quality, very functional VR scenarios using our existing assets in a very, very short amount of time. We can use it as a foundation and focus on what really matters, which is the surgical training and the skills that need to be given to the surgeon. So we're fully equipped to make these VR experiences, and I'm really excited to make them and roll them out to the world.
Hi, my name is Sinan Vural, and I am one of the founders of Non-Nosere and its Chief Technology Officer. We started in the medical industry in 2013. Our first mockup was created in the Unity game engine as a top-down view 3D linear game. We did come a long way since then. We created our first real product in Unreal Engine. We created different input and display methodologies. We created even more modules, but we always struggled to create new procedures quickly. We decided to develop a strong infrastructure that we would be able to expand upon. But this would have a big impact on our current business because we would need to stop all our operations and focus on creating this infrastructure. That's when we met ORama. It was the perfect timing because ORama had already put in the foundation that we planned to create. It was really easy for us to settle into the new rhythm. We created one of our procedures with the MAGES SDK in just 5 months. This included us learning the ropes and creating the simulation. Most of our potential problems have already been solved by the MAGES SDK, like VR setup, multiplayer, analytics. All we had to do was create the flow we needed. Of course, we had to develop some internal tools, but even this process was streamlined with the MAGES SDK. We were prototyping and adding new features not in months, but weeks, and in some cases even days. In fact, our fast turnaround had such a huge impact on one of our clients that we changed our business model. Where at the start our users were learners, now we design our platform catering to the needs of the educator, with an emphasis on multiplayer VR session that is sitting at the heart of the future curriculum design at prominent universities. So thank you, ORama.
Hello, good evening everybody. I'm Thomas Sauter, the head of the Division of Emergency Telemedicine, E-Emergency Medicine at the University of Bern in Switzerland. The aim of our division is to do research about and with digital tools, and it's supported by an endowed professorship funded by the Touring Club Switzerland. Together with my team, we've been working with extended reality and together with ORama for the last years. The Wiesel Inselspital Virtual Reality Lab is dedicated to do research about VR in medical education, but also in clinical practice. We do research and education about virtual reality, how to use it, and which way it benefits the most for the students. I want to talk to you about 2 projects we created with ORama. The first is the Reboa simulation. With it, I think it's an ideal use case for virtual reality because of the high costs for training, equipment, and also because the intervention, the Reboa catheter, is done not very often in the real life of an emergency physician. We use it to train our ED doctors and also to keep them updated and to avoid skill decay. The COVID simulation we created with ORama is the second I want to talk to you about. It's free for educators and medical professionals all over the world. It has been evaluated in an RCT and published recently in the Journal of Medical Informatics Serious Games. It's a simulation that trains the healthcare provider to do a COVID swab, and also it can be done in the multiplayer mode, which is really important for us because there we can train a group of people. I'm looking forward for the future collaboration with ORama and to push medical education in the future. I think that VR is the future of physical simulation, and we really have to learn a lot and to train a lot and to work together with the industry to get the best out of this new technique.
WGU's mission is to change lives for the better by creating pathways to opportunity. Often, this requires us to remove barriers to access. For our healthcare students, it's not always possible or even necessary for them to attend clinical facilities in person. And since many of our students are busy working adults, we knew we needed a virtual alternative. We wanted to understand the latest VR research and accelerate our innovation efforts so we could offer virtual experiences that were authentic and engaging for our students. Why did we choose ORamaVR? It was important for us to partner with an organization that not only had a significant amount of expertise in designing virtual reality simulations, but also the willingness and ability to innovate. And ORama welcome the opportunity to discover and learn with us.
Hi, my name is Karen Shader. I'm a senior program producer at Western Governors University. We worked with ORamaVR to design and develop what we consider the first of its kind, high-stakes virtual reality assessment. The assessment requires for learners to make decisions and successfully navigate patient engagements in a dynamic and completely immersive clinical environment. Students are telling us that they feel completely immersed and enjoy the novel, innovative scenarios. The virtual reality assessment helped them feel as though they were taking on the role of the care coordinator, which was one of our primary and immediate goals. We believe this validates our overall strategy for the use of virtual reality.
So what have we learned? Using a headset can elevate anxiety for a student who is already anxious about taking a high-stakes assessment. It's important to get them comfortable and confident long before the assessment starts. For those unable to overcome their anxiety, perhaps they feel claustrophobic when wearing the headset, it is important to offer an alternative. For us, that was a desktop version of the simulation. We also learned that some types of content changes more frequently than others and can be easier and faster to update when it is outside of the simulation. We're factoring that into our future designs. So what's next? We're currently analyzing our preliminary outcomes and learnings to inform future efforts. This includes identifying the scenarios and programs where VR can add the most value for our students.
Thank you everyone for sharing your stories with us. Now let me hand over to Niels Hebner, our Chief Business Officer, who will tell you more about MAGES App Marketplace.
Now that you understand the power of the MAGES products, let me tell you that you don't have to wait to develop or co-create VR simulations to start benefiting from MAGES. On the ORamaVR marketplace, you can directly subscribe to ready-to-use simulations developed by and for our clients or by ORamaVR. We call the ready-to-use simulations MAGES app. We currently have a number of them ready for you to download and subscribe to. Check them out on our website. There are paying and free versions available. If you already have created or co-created medical VR simulations powered by MAGES SDK, you can decide to make them available on the MAGES app marketplace. Let me recap our MAGES product line. The MAGES SDK, it is the toolbox you need to create highly realistic medical VR simulations efficiently without our help. The MAGES Sim, which we co-create with and for you, translating your expertise into customized medical VR simulations that respond to your specific needs. And the MAGES app, ready to use medical VR simulations created and now made available to you and the world. To support that, we work hard in bringing you the best technology can offer.
The last section is dedicated to our research and development team, where I will present you our company's future, starting with deep learning. For the last couple of years, deep learning has been an impactful technology across many industries as they are transforming our everyday life. ORamaVR is striving to bring this technology to all MAGES SDK developers, enabling them to create the most advanced, high-fidelity, complex medical VR training simulations more rapidly as well as more accurately. MAGES SDK provides sophisticated deep learning tools that enable developers to produce VR scenarios that the user can perform the way he or she is accustomed from the physical world. Features such as cutting and tearing are enabling the creation of actions that can be completed with infinite different approaches. As a result, the process of providing feedback back to the user becomes a lot more complex. If we have infinite correct ways to complete a task, how can we create a software agent that evaluates them? The ORamaVR team is building unique tools to tackle this issue by leveraging deep learning for VR. Developers that choose MAGES SDK will be able to train their own VR deep learning agents simply by playing their sessions and feeding this data to our DL algorithms. We hope that this new feature will make the process of authoring analytics rules straightforward, allowing developers to focus more on creating the visual and interactive part of the immersive scenario. Furthermore, as VR technology matures and development for it becomes more streamlined and low-code, developers can rapidly create more complex immersive scenarios faster. This leads to the necessity of more testing. This is why we are preparing deep learning agents that can learn the behavior of past users and imitate them to attempt to finish a VR scenario developed with MAGES SDK, allowing for realistic automated testing. This is undeniably the era of 5 and 6G. As these networking technologies mature, exciting and revolutionary capabilities are unlocked in so many research areas. ORamaVR takes a brave step and leads the research regarding VR medical training utilizing 5 and 6G networks. By participating already in 3 European Horizon projects with leading industry and research partners in Europe, we seek to enable the full potential that the fusion of these two emerging technologies can yield. VR medical training research, driven by ORamaVR, has produced many breakthroughs over the past decade. These advancements were accomplished by designing sophisticated graphics algorithms and exploiting the constantly growing specifications of GPUs for tethered head-mounted displays. Although untethered VR and AR HMDs enhance users' mobility, they still remain an area of many challenges, as they are bound by lower CPU, GPU, and battery specifications. Such limitations can now be overcome via the use of 5G and 6G networking capabilities. Our cutting-edge research allows heavy processing operations, such as rendering or physics principle calculations, to be executed remotely on powerful cloud resources. By offloading such processes, we enable even low-spec hardware to run our high-fidelity applications. Our users can enjoy a longer battery life, thus increased mobility. This is especially crucial for first-aid use cases, such as first responders, that can now use low-spec VR or AR HMDs on-site while communicating with command centers. With 5G worldwide coverage spreading every day, users from diverse geolocations can now coexist and collaborate in real time with minimal latency. We are proud to be able to support one of the highest number of concurrent users in a single virtual medical operation. The landscape of medical education has dramatically changed over the past years due to the pandemic. The great need for fast and efficient training of medical experts is no longer satisfied with traditional pedagogical approaches. A powerful tool that can help turn the tide of the ongoing pandemic is extended reality, or XR for short, which is the superset of virtual, augmented, and mixed realities. Medical experts all over the world use nowadays XR technology not only for the education of the next generation of medical personnel, but also to promote research and provide various insights that were previously omitted. Current research results prove that the visualization tools enabled by XR act as a catalyst in various scientific areas, such as neuroscience, biotech, and impacts all traditional medical methods, operations, and interventions. At ORamaVR, we are actively working towards the next evolution of computational medical XR metaverse by enabling both AR and VR participants with different headsets to actively interact in the same collaborative network medical XR simulation.
As you have seen by now, ORamaVR offers a robust and versatile product line that is all about democratizing and revolutionizing the way medical VR training is provided. First MAGES SDK, then MAGES SIM, and finally MAGES App. I will end this event with few key metrics. ORamaVR currently serves 16 major B2B clients worldwide with a strong upcoming pipeline, has won several major industry awards, attracted significant deep tech R&D grants, and has aggregated more than 4,000 registered completed training sessions. Finally, our business plan has received the Seal of Excellence from the European Innovation Council. Following up on this product launch, we will showcase the MAGES software development kit and all of its technical details during a dedicated webinar. Let's keep accelerating world's transition to medical VR, and in the meanwhile, on behalf of the whole ORamaVR team of computer scientists, life scientists, engineers, mathematicians, physicians, surgeons, technical and business directors, as well as investors and co-founders, we thank you for joining us today.